Welcome back to Mysterious Universe, the place where curiosity burns as bright as the stars themselves. Today, we're going to look at something so familiar, so constant, that most of us rarely stop to question it. The sun. That blazing ball of fire in our sky. The giver of life. The eternal clock that governs our days. But what if I told you, the sun is hiding secrets? Secrets so strange, so inexplicable, that even the best scientists in the world are still scrambling for answers. Why does the sun's atmosphere get hotter the further you go from its core? How do solar storms have the power to knock out entire power grids on Earth in seconds? Could the sun's magnetic field one day flip upside down, triggering global chaos? These aren't science fiction scenarios. They're very real mysteries that modern science has only just begun to uncover. And today, we're going to dive into 10 of the most mind-bending discoveries about the sun, mysteries that will make you rethink everything you thought you knew about the star that makes life on Earth possible. If you love unraveling cosmic secrets, if you want to explore the frontiers where science meets the unknown, subscribe to Mysterious Universe right now. Smash the notification bell so you never miss another journey into the mysteries of the cosmos. Because the truth is, the sun is not a simple, gentle star peacefully shining in the sky. It's a violent, unpredictable, living engine of cosmic forces. And the deeper we look, the stranger, U-2014, and more dangerous, U-2014 it becomes. Are you ready to uncover the fiery mysteries hiding in plain sight? Let's dive into the untold secrets of the sun. When we look up at the sky, the sun seems simple enough. A brilliant sphere of light, providing warmth, guiding our days. But peel back the layers, and you enter one of the most complicated, violent, and puzzling structures in the known universe. The sun is not a solid ball. It's a layered, dynamic engine of plasma and energy, each zone stranger than the last. Let's break it down. At the very heart lies the core, the sun's nuclear furnace. Here, under unimaginable pressure, hydrogen atoms fuse into helium, releasing energy through nuclear fusion. Temperatures soar to an astonishing 15 million degrees Celsius, 27 million degrees Fahrenheit. Every second, the sun fuses around 600 million tons of hydrogen, converting 4 million tons of matter into pure energy via Einstein's famous E=mc squared. It's not just hot. It's violent. It's chaotic. From the core, energy travels outward into the radiative zone. Here, photons, particles of light, are trapped, bouncing off atoms in a cosmic pinball machine. It can take a single photon over 100.000 years to journey through the radiative zone and reach the next layer. Then comes the convective zone. In this turbulent region, plasma bubbles up and down like boiling water. Hot plasma rises, cools slightly, and sinks again, creating massive convection currents that can span thousands of kilometers. Above this turbulent interior lies the photosphere, the visible surface of the sun. This is what we see from Earth, glowing in brilliant yellows and whites. The photosphere's temperature? A relatively mild, approximately 5.500 degrees Celsius, 9.932 degrees Fahrenheit. Compared to the core, it's almost chilly. But here's where things get bizarre. Above the photosphere lies the chromosphere, a thin layer where the temperature mysteriously begins rising again. And beyond that, the most baffling layer of all, the corona. The corona is the sun's outermost atmosphere. It extends millions of kilometers into space, forming the magnificent halo we see during a total solar eclipse. Its temperature? Over 1 million degrees Celsius. That's right, the sun's atmosphere is hundreds of times hotter than its surface. How can this be? How can moving away from the core, away from the fusion engine, result in higher temperatures? It defies everything we understand about heat and distance. This is known as the coronal heating problem, and for decades, it has puzzled the greatest minds in astrophysics. Several leading theories have emerged. The first involves Alfvén waves, named after physicist Hannes Alfvén. These are magnetic waves that ripple through the sun's plasma, carrying energy outward from the convective zone. Some scientists believe that under certain conditions, these waves transfer their energy into the corona, superheating it. But detecting and measuring Alfvén waves in the chaotic environment of the sun is incredibly difficult. Another theory points to magnetic reconnection. The sun's magnetic field is in constant flux, twisting, tangling, and snapping apart. When magnetic field lines break and reconnect, they release bursts of energy, heating the surrounding plasma. This could contribute to the corona's searing heat. And then there's the nano-flare hypothesis, proposed by legendary solar physicist Eugene Parker. According to this idea, the corona is being constantly bombarded by tiny, almost undetectable flares, each releasing just a whisper of energy. Individually, they're too small to notice. But collectively, billions of these nano-flares could pump enough heat into the corona to account for its blazing temperature. It's like an invisible forest fire, where countless tiny sparks keep the blaze alive without a single towering inferno. And yet, none of these theories fully explain everything we observe. The solar corona remains one of the strangest, most mysterious structures in the solar system. Is there some unknown force at work? Some hidden particle interaction? Some new physics that transcends our current understanding? The sun challenges us with a paradox. The farther you go from the source of energy, the hotter it gets. It's as if the universe is reminding us that even with all our knowledge, there are realms where the rules bend, or where the rules have yet to be discovered at all. The more we stare into the heart of the sun, the more it stares back, daring us to unlock secrets millions of years in the making. And this is only the beginning. Because when you look beyond the surface, when you peel away the dazzling light, you find chaos. You find violence. You find mysteries that shake the very foundations of science. And in our next chapter, we'll dive into one of the sun's most unpredictable forces. Its magnetic madness, and how it could one day turn our entire planet upside down. If you think the sun is a calm, glowing ball of light, think again. Beneath that blinding brightness lies one of the most chaotic, violent magnetic systems in the known universe. The sun's magnetic field is a swirling, twisting, ever-changing tangle of energy, a magnetic monster that stretches millions of kilometers into space. At any given moment, the sun's surface is a battlefield of magnetic forces. Lines of magnetic energy emerge from below the photosphere, loop out into the corona, and then plunge back down again, creating vast, glowing arcs called solar prominences. Sometimes these magnetic fields become so twisted, so tangled, that they snap violently, unleashing solar flares and coronal mass ejections, CMEs, that blast billions of tons of plasma into space. And this madness isn't random. It follows a hidden rhythm, the 11-year solar cycle. Every 11 years, the sun's magnetic poles flip, north becomes south, and south becomes north. It's a reversal that unleashes titanic forces. As the solar cycle builds toward its peak, called the solar maximum, the sun becomes increasingly unstable. Sunspots, massive dark patches of magnetic activity, multiply across the surface. Solar flares become more frequent and powerful. And the chance of a devastating solar storm skyrockets. But here's the mystery. How do these sunspots, these massive magnetic scars, form into towering, twisted structures that can store so much destructive energy? Sunspots are cooler than the surrounding photosphere because intense magnetic fields prevent the normal flow of heat. They appear dark because they're about 1.500 degrees Celsius cooler than the surrounding surface. But the real drama happens beneath. Sunspot regions are connected by loops of magnetic flux, gigantic structures larger than Earth itself. These loops can tangle, twist, and shear against one another, building up immense magnetic stress. And sometimes, without warning, they snap, releasing energy equivalent to millions of nuclear bombs exploding simultaneously. Scientists are still trying to fully understand what triggers these catastrophic magnetic collapses. And when they do happen, the effects can ripple across the solar system. The most terrifying example? The Carrington event of 1859. On September 1, 1859, astronomer Richard Carrington observed a brilliant flash of light on the Sun, the first recorded observation of a solar flare. Hours later, a monstrous CME slammed into Earth's magnetic field. The effects were catastrophic. Telegraph systems across Europe and North America failed catastrophically. Some telegraph operators reported sparks flying from their equipment, starting fires. Auroras, normally confined to the polar regions, were seen as far south as the Caribbean. If a Carrington-level event struck today, the consequences would be unimaginably worse. Modern society is far more vulnerable than it was in 1859. Our world now depends on satellites, GPS, electric grids, internet infrastructure, all delicate systems that could be fried in minutes by an intense solar storm. Estimates suggest that a major CME impact could cause trillions of dollars in damage, plunge cities into darkness for months, and cripple global communications. And here's the chilling part. Solar scientists warn that we're overdue for another Carrington-class event. The Sun's magnetic cycles continue unabated, building and releasing energy on a colossal scale. And while we can monitor solar activity and issue limited warnings, we still have no way to stop, or fully predict, a massive solar storm. Some researchers have proposed that superflares, even more powerful than the Carrington event, could be lurking in the Sun's future. On other stars like ours, superflares have been observed that are 10 to 1,000 times stronger than anything we've yet experienced. If one of these superflares erupted from our Sun, it could devastate Earth's technological civilization in a matter of minutes. Power grids would collapse. Satellites would be disabled. Air travel would halt. Financial systems would crash. In an instant, we could be hurled back into a pre-electric era, not for hours, but potentially for years. And right now, there's no global infrastructure capable of withstanding a full-scale solar apocalypse. Which raises a sobering question. Are we prepared? Or are we quietly standing at the edge of a cosmic minefield, blind to the ancient magnetic rage building just beyond our sky? The Sun, for all its warmth and light, is a creature of chaos. Its magnetic fields twist and churn in endless, restless cycles, brewing storms that could, at any moment, reach out and remind us just how fragile life on Earth truly is. And the next time, we might not be so lucky. In our next chapter, we'll dive even deeper into the explosive events that launch billions of tons of solar material into space, and the terrifying forces that make them so unpredictable. Solar eruptions, the mysteries that science still struggles to explain. If the Sun's magnetic fields are a coiled spring of energy, then solar eruptions are the moments when that spring snaps, with catastrophic force. Two of the most violent phenomena we know of are solar flares and coronal mass ejections, CMEs. Both are sudden, explosive releases of energy and plasma from the Sun's atmosphere. Both can unleash forces that dwarf even the most powerful nuclear weapons humanity has ever built. But what makes them truly terrifying is how little warning we get. Solar flares are massive bursts of electromagnetic radiation. They erupt when magnetic fields near sunspots become unstable, twisting and reconnecting with a sudden, explosive snap. In an instant, energy built up over days or weeks is unleashed into space as X-rays, ultraviolet radiation, and energetic particles. The largest solar flares release as much energy as 1 billion hydrogen bombs, all packed into a blast that can cross 150 million kilometers to reach Earth in mere minutes. The impact? High-frequency radio blackouts. GPS disruptions. Dangerous radiation levels for astronauts and airline passengers. But solar flares are only part of the story. Sometimes, an eruption doesn't just release light and radiation. Sometimes, it launches billions of tons of plasma into space. This is a coronal mass ejection, CME. A CME is a literal blast of solar atmosphere, massive clouds of charged particles hurled outward at speeds exceeding 2 million kilometers per hour, over 1.2 million miles per hour. Imagine a mass of superheated gas heavier than Mount Everest being hurled across space faster than a speeding bullet, and you begin to understand the sheer scale of a CME. And yet, despite the sun's overwhelming gravity, despite the immense weight of the plasma, these CMEs are launched seemingly effortlessly. How? Scientists have been trying to solve this puzzle for decades. Traditional theories focus on magnetic reconnection, the sudden realignment of magnetic field lines snapping like rubber bands under extreme stress. When magnetic fields collapse, they can catapult plasma outward like a slingshot. But recent research proposes an even stranger possibility: quantum fluctuations. Some scientists believe that tiny, almost undetectable quantum variations in plasma particles, minute shifts in energy at the subatomic level, might trigger magnetic collapses on a massive scale. In other words, a microscopic instability in the sun's plasma, a fluctuation smaller than an atom, could, under the right conditions, unleash an explosion capable of disabling technology across an entire planet. It's a chilling thought. The fates of satellites, power grids, and global communications might hinge on quantum events we can barely detect. And it gets even scarier, because CMEs often happen without clear warning. Despite the array of satellites and solar observatories watching the sun 24/7, many major CMEs erupt without obvious signs beforehand. One moment, the solar surface is calm. The next, a billion tons of plasma are racing toward Earth. When a CME is Earth-directed, it collides with our planet's magnetic field, compressing it, distorting it, and injecting massive amounts of energy into the upper atmosphere. The potential consequences are staggering. Satellites could be fried by high-energy particles. Navigation systems could become wildly inaccurate. Electric power grids could collapse under induced currents. Radio communications could be disrupted for days. The internet itself, particularly undersea cables relying on precise timing, could suffer massive, long-term outages. Scientists estimate that a strong, Earth-directed CME could cause trillions of dollars in economic losses, take years to fully recover from, and, in extreme cases, disrupt global society at a fundamental level. And because these solar monsters travel so fast, we might only get 12 to 24 hours of warning, barely enough time to brace for impact. So, what are we doing to protect ourselves? NASA, ESA, and other space agencies monitor the sun closely, using satellites like the Solar and Heliospheric Observatory, SOHO, and the Parker Solar Probe. Early warning systems are being developed to give power companies and governments precious hours to shut down systems before damage occurs. But the reality is stark. There's still so much we don't understand about how solar eruptions begin. We can predict when the sun is more active, during solar maximums. But predicting a specific eruption, its strength, its direction, its timing, remains largely beyond our capabilities. It's like standing next to a sleeping dragon, knowing it could awaken at any moment, and hoping it doesn't breathe fire in your direction. So we're left with a sobering question. How much do we really understand about the fury of our own star? As we rely more and more on delicate technologies to run our lives, our vulnerability to solar eruptions grows. The sun is not a gentle life giver. It is a roaring, restless engine of creation and destruction. A cosmic beast whose moods could, at any moment, reach out and change the course of human history. And if we fail to listen to its warnings, we may pay the price sooner than we think. In the next chapter, we'll explore the deepest, most personal mystery of all. How much does the sun truly control life on Earth, and could it decide our ultimate fate? When we think about the sun's importance to life on Earth, we often think simply. It gives light. It gives warmth. Without it, life would perish. But what if I told you? The sun doesn't just make life possible. It controls life. From the smallest microscopic organism to the largest ecosystems. From the rise and fall of civilizations to the great extinction events of history. The sun has been the invisible conductor of the symphony of life on Earth. Our biological rhythms, our circadian clocks, are set by the sun. Every creature on Earth, from bacteria to humans, is tuned to the daily cycle of light and dark. Plants open their leaves to the sun, photosynthesizing sugars that fuel the food chain. Animals migrate, breed, and hibernate based on the seasons dictated by the sun's angle and intensity. Even our mood, hormone levels, and mental health are deeply tied to the solar rhythms that have governed our world for billions of years. But the sun's influence goes far deeper, and far darker than simple daylight and warmth. Because the sun's energy output isn't constant. It fluctuates over time, subtly, but with profound consequences. And when those fluctuations become extreme, they have the power to reshape the very course of life on Earth. Throughout Earth's history, there have been dramatic periods of climatic upheaval. Mass extinctions. Global ice ages. Shifts in atmospheric composition. And increasingly, scientists are looking at the sun as a possible trigger. One of the most chilling examples is the Maunder minimum, a period from about 1645 to 1715 when sunspot activity virtually disappeared. During these 70 years, the sun's magnetic activity, and likely its energy output, dropped dramatically. The result? The Little Ice Age. Temperatures across the northern hemisphere plunge. Glaciers advanced. Crops failed. Famines and societal collapses spread. The Thames River in London froze solid. Winters became brutally cold. Summers grew shorter and cooler. It was a chilling reminder that even small changes in solar output can have devastating impacts on Earth's climate and therefore, on human civilization itself. And this was just a relatively mild fluctuation. Imagine if the sun entered a prolonged period of extreme variability. A decrease in output could plunge the Earth into another deep freeze, crippling agriculture and triggering mass starvation. An increase could unleash runaway global warming, drying out ecosystems, sparking massive wildfires, and shifting weather patterns beyond recognition. Some scientists even theorize that the sun's longer-term cycles, over thousands or millions of years, could help trigger major extinction events. Perhaps the Permian-Triassic extinction, the greatest die-off in Earth's history, was partly driven by solar changes coupled with volcanic activity and ocean anoxia. Or perhaps the cycles of glaciation that have shaped human evolution were influenced not just by Earth's orbital dynamics, but by subtle, ancient variations in the sun's heartbeat. Today, we're entering a new solar cycle. Solar Cycle 25 began in late 2019, and predictions suggest it could be more intense than its predecessor. But truthfully, we don't fully understand the sun's long-term rhythms. The sun could lull into another Maunder minimum tomorrow. Or it could ramp up into unprecedented activity. And if it does, we have little power to stop it. We like to think of humanity as the masters of our own destiny. We build cities, we fly to the moon, we bend nature to our will. But ultimately, we are still creatures of the sun. Our crops, our climates, our technologies, our very bodies. They are all tuned to the whims of a star we barely comprehend. The sun nurtures life. But it also holds the power to end it. Its warmth is a gift. Its rage could be our undoing. And so, we are left with a haunting question. Is Earth's future tied, inseparably, to the moods of the sun? Are we riding a cosmic wave, at the mercy of forces far beyond our control? Barely aware of how fragile our existence truly is? The sun, our eternal companion, remains both life-bringer and life-destroyer. A burning heart of mystery. A force of unimaginable power. And perhaps, in the end, the greatest mystery of all is how little we truly know about the star that defines our existence. The sun has been with us from the beginning. Before there were cities, before there were languages, before there were even dreams. There was the sun. Its light touched the first oceans, awakening the chemistry of life. Its warmth stirred the winds, shaped the landscapes, nourished the first forests. Every breath we take, every heartbeat we feel, every step we make, all of it is powered by a star 150 million kilometers away. But as we've seen tonight, the sun is not just a giver. It is a force of unimaginable power, wonder, and mystery. It shapes the rhythms of our bodies. It controls the climates of our world. It harbors storms so vast they could erase our technologies in an instant. And despite our satellites, our supercomputers, our centuries of study, we have only just begun to glimpse the true complexity, the true majesty, the true danger of the star we call our own. So what do we do with this knowledge? Do we fear the sun? Do we curse its unpredictability? Or do we do something better? We choose wonder. We choose curiosity. We choose exploration. Because in facing the awesome mysteries of the universe, we discover something even more powerful than fear. The unbreakable human spirit. The spirit that dares to ask questions that have no easy answers. The spirit that builds spacecraft to touch the very fires of the sun. The spirit that dreams not just of survival, but of understanding. At Mysterious Universe, that spirit burns brighter than ever. If this journey into the heart of our sun sparked even a flicker of wonder inside you, subscribe now. Tap the notification bell to stay with us on every new cosmic voyage. Share this video with fellow explorers, because knowledge grows when it is shared. Leave us a comment below. What mystery of the sun fascinates you most? We would love to hear your thoughts. Because together, as a community of dreamers, seekers, and pioneers, we can light up the darkest mysteries of the cosmos. The sun gave us life. And in its endless dance of creation and destruction, it reminds us of something profound. That to be alive, truly alive, is to keep reaching for understanding. Even when the answers lie beyond the horizon. Thank you for being part of this journey. This is Mysterious Universe, where the spirit of exploration never sets. We'll see you in the next great mystery.